So as we're getting ready to go to the AP exam, there are some terms that I want to make sure that you have picked up on, or if you haven't, that I want to make sure you've got. You will see is a versus has a relationships. You may see questions on that. If you watched my recordings on inheritance, and some of those were very good with the terminology that you'll see on the AP exam, so I hope you had a chance to watch them. Those are is a relationships, and I believe I mentioned that in the lecture, that we say child is a parent. So border collie is a dog. Dog is a mammal. So is a always designates inheritance. And we recognize inheritance because we will see in the subclass or the child class the word extends followed by the superclass or the parent class. So when we're talking about is a relationships, that is always going to be inheritance. Now there's also a has a relationship that is referred to as composition. And this website here has a pretty good summary of it. I'll try to remember to send you the URL to it. So we talk about object-oriented, and object-oriented is always going to have the ability for is a and has a relationships. I've already talked about is a, which is based totally on inheritance, and we identify is a relationships by finding the keyword extends that connect to classes. All right, has a relationship, and I may have talked about a little bit about interfaces in that, but I really was not thinking clearly when I said that. Has a relationship is when one class has a reference to another class in it. So one class may have as an instance variable the creation of an object of another type of class. And so we call that composition, and that is referencing the use of instance variables that are references to other objects. I'm not talking about a string or an int or a Boolean instance variable. I'm talking about instance variables that specifically are references to other objects, and there's no, technically we say there's no keyword that identifies a has a relationship, but in theory there is. It's the keyword new, right? When you're doing the creation or instantiation of an object and you use the word new. So if you see the word new in one class creating an object of another type of class, that is a has a relationship. And so here's a pretty good example. We see that we have a superclass or a parent class called car. We have an is a relationship that immediately tells me inheritance, that this one, Maradi, whatever that is a child. It's a type of car. I'm sure it's a sports car or something like that. So this is an basic inheritance diagram. Notice the arrow is going to go from the child to the parent. The parent's going to be higher than the child, but the arrow is going to go up. So this indicates that Maradi extends car. Okay? Now notice here we have has a, not an arrow but just a line with the words has a, and we have class engine. What this tells me is that in the Maradi class there is a reference to, there is an instance variable that creates an object called of type engine. So if we look at the car, we see our typical instance variables and some methods. This is our parent. Then we look at the child, Maradi, we see it extends car, so here's our inheritance, okay? And this is our is a relationship. And now if we look at this child, we see in it the creation of an object named Maradi engine. Here's my keyword new, and this is not just a basic string or int, simple instance variable. This is actually the creation of an object of type engine. So that is my has a relationship right there. When I see one object being created inside of a class, and here's the engine class, that is composition, or we call it a has a relationship. So Maradi has a engine, and that's how you interpret that. All right. So we see here that when we come into our main, we can create our Marathi child, right? And we've got color, speed, car info, and all of that good stuff. And that comes from the parent. Car is where those are. All right, so there are a couple good points here. It is easier to change the class implementing composition than inheritance. The change of a superclass, anytime you change the superclass, you impact all of the subclasses that inherit from it. And if you make enough changes to the parent, depending on the types of changes, you may actually have to go touch every subclass. So if I have a method in the parent and I take it from a void to returning a string, you know, I have to think about, is there going to be any impact to that in the child class? Not necessarily, but I still have to think about that. I might have code in main where I'm using a child and I'm calling a method from the parent where I expected it to be void, and now it's returning a string. So I've got to go touch my main, for example. But depending on the changes you make in the parent, if you change the constructor of the parent and you're invoking that via super in the child, now you've got to touch all the children and make sure you're passing an extra parameter, for example. So there are things that when you change in the parent, you have to think about the ripple effects that possibly affect the children. Composition is what we call dynamic binding, and inheritance is static binding. So when we have inheritance, when we compile, all of the code from the parent is more or less copied, you could think of it as, into the child file. That happens at compile time, so that now that child file has reference access to everything in the parent. And that's compile time, or static binding. Happens before you ever run main. Okay, that happens when you save and compile. Whereas composition is dynamic. So the connection between those classes that have composition happens at runtime, not when you save and just compile. So there's a little bit of a difference there. And so this makes some good points here about being careful when you change the parent. You can dramatically impact the children if you're not careful. But then they make the point it's easier to add new subclasses to just keep extending from the parent than it is to add new composition relationships. All right. In any case, whether you have composition or inheritance, you just have to be careful when you make changes because of possible ripple effects. Okay, so that's the difference between IsaHasA and HasA, and you may see diagrams like this. This indicates child and parent. This indicates that this one has in it the creation of an object of this type of class. So take a look at that. Take a look at this example. I'll send you the URL, and just think about inheritance versus using one class to more or less be an instance variable in effect in another class, which is perfectly legal and not that much different from anything else that you've done. And hopefully this little tutorial will help you on the AP exam. One other thing I wanted to show you quickly is a slightly different version, more in the UML, Unified Modeling Language style, to designate relationships. So we saw a very simple inheritance diagram. This is a little more involved inheritance diagram. But what it's telling you is, notice again, child is lower than parent. The arrow goes up, that indicates checking account is a bank account, so there's our inheritance relationship. Notice that in this type of diagram, the class name will be at the top with an underscore underneath it, just like you see here. In this first rectangular block will be any instance variables, their names and their data types. Account ID is a string, balance is a double. And then in the lower rectangle of the 3 rectangles, the lower one will have method names in it. So here, for example, the first rectangle will always have the class name. It does in both cases. This is inheritance. The parent's second rectangle is showing its instance variables and their type. The child does not have any of its own unique instance variables. It is going to reference the ones in the parent. So in this case, that is blank. And then we have our methods that are in the parent, and here we have our methods that are in the child. You can also, of course, if the checking account has its own instance variables, you can have those as well.